This is paper 2, video 2 for the February mock. The first topic we're going to look at is probability. So in this scenario, we've got a 4-digit code, we've got the first part of the code, we need to do something involving this last number. So we've got that the last digit is even but not 6. So the first thing I would do is write down all the possible things that we've got that would work with that scenario. So even but not 6, so that final number could be 0, 2, 4, can't be 6, but it could be 8. If he's going to choose a different even number at random, the probability that he chooses the correct number, so basically the probability that he's going to pick one of these correctly, would be 4, because there are 4 possible numbers that would be even and not 6, out of 10, because in total there are 10 numbers from 0 up to 9, so just 4 out of 10 for the probability. The second question is a little bit of a follow-on question, but actually is a little bit different in what it's asking. So we've got a different 4-digit code. We've now got that the 4-digit code is an odd number. Now that doesn't mean that each of the digits is odd. That means that altogether the 4 digits will be odd. So it's actually only the last number that we need to be odd. If the first digit is 4, we need to look at the possible codes that we could have and how many different combinations there are. So we've already said that the first number has to be 4. The next 3 numbers, we need to work out what they can be. So the second number, there's nothing to stop that being any of the 9 digits. So that could be anything from 0 up to 9. Therefore, there are 10 possible numbers that one could be. Same applies for the next number. There's no restrictions on the third number here. So again, there are 10 numbers, 0 up to 9, that could be. The final number, however, it does say that the 4-digit code is going to be an odd number. So that means this has to be either 1, 3, 5, 7 or 9. So here, just 5 combinations. If we want to know how many different combinations there are altogether then, taking into account all of these provisos, all we actually do is we multiply together the number of numbers that we can pick from each time. So 10 times 10, 100, times by 5 gives us 500. That means there are 500 different combinations in total that the pin code could be. For the next question, we're going to look at plotting graphs. Now the main bit I'm going to focus on this is actually working out the values that you would need to put into your table and therefore then plot onto your graph. So as I said, the first thing I would do in a scenario like this, if there isn't already one drawn, is get myself a little table of values drawn onto the exam. Now normally the x values goes from -3 to 3. Here it's changed it just slightly, so it wants the values of x to go from -2 up to 4. Now at this point, with this being a calculator paper, this actually does become a little bit easier because we can get the calculator to do all the calculations for us. In order to do it, if we take the first number, so -2, all I'm going to do is substitute that into the equation that we've got at the top of the page. So we would get that y is equal to, now because I'm doing this on a calculator, they aren't that intelligent, they do need to be programmed fully into what you're doing. I would put the little -2 into brackets and then square it. Take away 2 lots, again because it's a negative number, I'm going to put the little -2 in brackets, and then it says take away 3, so I'd take 3 away. If you're doing this without a calculator, that would mean that we get 4, take away 2 times -2 is -4, take away 3, so that would actually give us 4 plus 4 minus 3, so 5. I'd then keep doing exactly the same thing with each of the other numbers in the table. So minus 1 in brackets squared, minus 2 lots of minus 1, again, little bracket around the minus 1, take away 3. So this would give us 1, take away 2, or take away minus 2 should I say, minus 3, so that gives us 0 for this one. For 0, don't need the brackets around now, because we're talking about a number that doesn't have a minus in front, so we're okay just leaving this as follows. That would give us minus 3 if you did it on your calculator. And then I'm just going to keep doing the exact same thing. Obviously with the positive numbers we don't need to put the little brackets round. So just as one final example, if we were to say y equals 1 squared minus 2 lots of 1 and take away 3. Here we get 1, take away 2, take away another 3, so that gives us minus 4. The other values look like this. You can check these on your calculator to see if you get the same thing. Again, the axes should be drawn in the exam for you. So they'll look something a little bit like this. And you'll end up with a little graph that you will need to make sure that you join all the points together with a nice, smooth, continuous curve. Keeping with the graph question, here is a graph pre-drawn in the paper for you. It says down at the bottom they need to pick out the 3 significant points of this quadratic curve. Well, those 3 points are basically where it crosses the different axes, so different points here. Now these two here, so this one and this one, these are known as roots of the equation or roots of the graph, also known as solutions. These are the points that would actually give a solution to the equation if, for instance, it was equal to 0. So if this had been the same equation as on the last page, like so, these 2 coordinates here would be the values of x that would make this 0. The other coordinates of interest is this one here. That is where it crosses the y-axis. Here it crosses at 0, minus 3, which if you link back to this is actually the point where x equals 0, so y would equal minus 3. And there is actually a 4th interesting point here, and that's this. This point right down here at the bottom, that would be known as the turning point of the graph. The next topic, again, is all to do with probability, but given in a very different way. So here we've got a scenario that a bag contains counters. We've been given some information about the number of counters in the bags. However, for blue, green and yellow, the information has been given in terms of x. We're told in the question that the probability that we pick out a red counter is 9 out of 100. So this is quite nice actually in this question, because it does say there are 9 red counters. So if the probability is 9 out of 100 and there are 9 red, that tells me that there are 100 counters in total. So if I now know how many counters there are altogether, what I can do to try and find out what value of x we would need to make this correct is I can actually think, well, if we add together the number of counters according to the table, so here we've got red plus blue plus green plus yellow, if there are 100 counters in the bag, these should add together to make 100. Simplifying this bit on the left hand side, we would get 3x plus x is 4x plus another 2x, so 6x. 9 take away 5 would give us 4. So we get that 6x plus 4 equals 100. We take 4 away from both sides. This gives us 6x equals 96. And then I'd divide both sides here by 6. So x is equal to 96 divided by 6. Don't forget you've got a calculator for this question if you need it. So that would give us 16. So x would be 16. The question does say that we want to work out the probability of green. So if x is 16 and green was x minus 5, for green we would have to do 16 take away 5, which is 11. So there are 11 counters altogether. Just in case you asked for the other ones, 3x would mean we had to do 3 times 16, so 48. 11 we've found. And 2x, so that'd be 2 times 16, 32.